So now it's my job to introduce our fantastic first keynote speaker, Laura Veldkamp, professor of finance at Columbia Business School. Maybe a less known fact that her first faculty job was actually right here at INSEAD. So it's only even more fitting to have her speak at this particular edition. But of course, the main reason that we wanted to have her here is her research. So she will talk to us about valuing data as a new asset type, and that's been the theme of her research for several years, at least. She's written a book about it, a string of papers, published papers on the topic, and more coming. And I think it's pretty clear that data is one of the central themes of the modern economy, and it's quite pressing and urgent to develop approaches to value it. So without further ado, here to tell us all about it, please welcome Laura Veldkamp.
Thank you. Thank you very much. Oh. Okay, maybe I need to stay away from that or from you. I'm not sure. Yeah. Thank you. All right, pleasure to be here. It feels like coming home to a place that's a lot of warm feelings. And so thank you for inviting me. This is this is not a paper. This talk will be based on a number of papers, and I owe an enormous debt of gratitude to the co-authors on these papers. They include work with Simona Addis, Juliana Begenau, Cindy Chung, Jan Eckhout, Mariam Farboudi, Adrien Matre, Roxana, who's here, Guillermo Ordonez, Jacopo Perigo, Thomas Philippon, Dhruv Singhal, and Venki Venkateswaran. Okay, so we're in this realm, this era of big data, lots of discussions, raising lots of questions. We all know at some level that the most valuable firms in the world today are valued largely for their data, right? But we don't really know how much. This raises a whole agenda of questions, theoretical, empirical, that touch on many aspects of economics and finance. Data is this new type of asset. We could call it an asset class if you want. And how do we price it? So I'll talk a lot about that today. But it relates to other questions like, how do we measure monopoly power, right? If we've got these really big firms with valuable assets that they might become entrenched and have market power in the markets they operate in. And so how would we think about reasonable harms to assess malfeasance, right? That's about the value of the asset. Is GDP measuring the value of an economy correctly? I'll touch on that before we get into valuation. And does the value of data vary? For example, like what happens when we change interest rates, right? How does the value of this asset fluctuate? I'm not going to answer all of these questions. I probably won't satisfactorily answer any of them today, but these are an agenda. These are questions that we want to chip away at, and it'll take many, many papers and many people contributing to do that. But the bottom line is we have these kind of industrial era economics tools, right? Still, most of finance is based on the foundation of there's capital and there's labor and there's TFP, and they come together and they produce widgets that one person can use at a time. And that's not what you do. It's probably not what most of the people you know do. It just doesn't really describe the modern knowledge economy. So how might, if we rethink those foundations, what implications does that have for valuations and the functioning of markets? Okay, so how do we start on this agenda? It begins with measuring the amount and the value of firms' data. If we can't do that, we're not going to get very far with any of these questions. So I'll begin with, what do we mean by data? Let's just get our vocabulary straight, because it relates to a lot of different concepts that many people in this room have thought about. We'll talk about some data economy mechanics, about how it's a byproduct of transactions, about how you buy and sell data, about how we depreciate data, because we got to get the depreciation rate right if we want to value this asset. And then I'll go through different ways, approaches to measuring and valuing data. I'll go through 6 approaches, and they're by no means exhaustive, okay? There are many, many ways to skin this cat. And we'll just talk about a few ones that have, differences and think about what their differences are, and conclude with some ideas about where next. So what's data? Data is information. It's just digitized information. It's information that's encoded as a binary code. Now, that's very, very broad. The data of interest is big data, right? Why are we having this discussion now? We've had information in some form for millennia, right? And going back to, scratching on tablets of Babylonians. Well, why we're having this discussion here and now is we've got these new technologies for processing data that have made data much more valuable than before. But these technologies really work when you've got an immensely large data set. Right? So what we're interested in are types of data that you could gather in great volume. And so that's often not, stitched together piece by piece, discovered in a lab or something like that. That wouldn't be enough volume of data. It's usually a byproduct of economic activity. Why can we get an enormous amount of it? Because we're counting every click on the internet. We're measuring cars that drive through a city. We're, checking what do you have in your basket right now? What set of goods? At what time did you check out? What kind of operating system are you using? Because we can just track this stuff that everybody does normally in their daily life, we can just generate vast amounts of data. So that's the kind of data that we're talking about. So how does this relate to the discussion about AI and machine learning? I'll use AI as sort of a stand-in for all kinds of technologies that require a large volume of data. This is about AI, but data is the fuel for AI, right? Data is the fuel, AI is the machine, and out of that we get better predictions. Right? So those better predictions might be labor displacing. Those better predictions might be like an asset of the firm or help the firm increase their productivity. But you really want to think data fuel, AI machine generates value. Okay? So this will be the input. I'm not going to talk quite as much about AI itself, not because it's uninteresting, but because I think just like with the Industrial Revolution, the machines turned out to have fairly standard economic properties. A lot of the interesting economics was in the fuel. There's a lot of interesting economics in the data fuel as well. So this notion of data makes it distinct from technology, patents, learning by doing, and algorithms, although it has similarities with each. So ideas and technologies, these are really procedures or concepts, right? And that's not the same as a prediction. Data could be an input into technology discovery, right? We've all done that, use data to create or back up, to verify new ideas. But it's not the same thing as a procedure or a concept. In particular, we don't usually get ideas as byproducts of producing more clickers, right? If we do this over and over and over again, we might get a little bit better at it, but probably a patent won't fall out of it, right? Whereas we might just generate data by seeing who buys these things. Learning by doing is similar in that it's a byproduct of economic activity, right? As we produce more and more clickers, we might get more efficient at clicker production. That's learning by doing. But that's often because a person gets better at doing it. It's human capital owned by a worker or maybe a team of, a management team. But typically it's not tradable. Right? And one of the things we'll talk about is that data is a tradable asset. This gets purchased and sold, and we can put a price on it and have a market for it. And lastly, data is similar to algorithms in AI, but it's the fuel for those. Okay? All right. So let's start with the basics. How is data generated and accumulated? So I like using this cartoon from the New Yorker. Oh, the text is a little fuzzy. So we've got kids at a lemonade stand, very classic activity. Grown-ups are enjoying the cup of lemonade, and it says, it's free, but they sell your information. Okay, so a modern take on the kids' lemonade stand. But I want to talk about this as a metaphor for a lot of different transactions that are going on in the data economy. This raises the question, was this lemonade free? Well, there was no money paid for it, but there was something of value was given to the kids at the lemonade stand that they presumably are going to monetize, right? So this is an example of a barter trade. The adults gave up some data, some information. The kids gave lemonade in return, and the kids will be able to sell that data and get some value for it, right? So this would be counted as zero for the purpose of measuring GDP, investment, consumption, anything else, because we always weight things by their prices. But there was a valuable economic exchange that went on here. Okay, so this is just a piece of what's going on in the data economy, and I'll come back to sort of examples of lemonade transactions or partial lemonade transactions as we go on. But what I want you to have in mind is this sort of transaction where data is being given in return for something valuable. And sometimes money also changes hands at the same time, right? In this case, there was zero price, but you could imagine they paid $1 and gave their data. But if they hadn't given their data, the lemonade might have cost $2, right? And if you think about what should have been the accounting, right? If we could have broken this up into 2 transactions. We could have had the kids sell the lemonade and charge $2, and the adults sell their data, and the kids pay adults $2 for anyone willing to sell their data, right? That would have been an equivalent set of transactions. We would have had net no money changed hands. Lemonade went one way, data went the other. But if we'd broken this up into 2 transactions where the $2 went one way and then the other way, we would have had $4 of economic activity, okay? Okay. So that then brings us to, there is an economy of free stuff, right? Mostly free digital apps that we use on our phones and computers and so forth. And that's a piece of the economy, and there have been some people who take a crack at measuring it. And it's not that big a piece of GDP, and okay. But I think it's just the tip of the iceberg. So now imagine this scenario. We've got a customer here, we've got a firm, and they pay money to the firm for a basket of goods. Okay, so money's flowing this way, basket of goods is flowing that way. But something else is moving at the same time. Something else is being transferred, which is data about this customer. Okay, so some valuable data will be revealed in the process of doing that transaction. So the customer is transferring valuable data. Presumably this firm knows how to value this data. Either they sell it or they use it to be more productive, or lots of things they could do to extract value from it. And so as a result, this firm really wants to do more transactions. Now, all firms want to do more transactions, right? But this firm has an extra motive to do more transactions, which is the data that they get, not just the money. And because they've got this extra motive to do transactions, well, how do you get more transactions? You either have to invest more in your product or making it better or marketing it to make it seem better or something, or you drop the price. Right? And better products for the same price or lower price for the same product, that's kind of isomorphic. They're going to have to offer more for less if they want to get more customers in. And so what they're implicitly doing is providing a slightly lower price for this good. And so what's happening is that part of the payment, part of the compensation to the firm is money, and part of it is data. So I'm going to argue that there's probably data barter going on with just about every transaction that we do in the data economy. Some of them will be pure data barter, like the lemonade stand, but a lot of them will look like this, where the customer isn't even aware that they're sort of implicitly selling their data. The firm may not even be aware that it's giving some discounts for data. It just is going to go find the profit maximizing price. And as long as in the process of finding the profit maximizing price, they think about the value of data, they think about their long-term profitability, not just the profitability of this particular exchange, then we're going to see some form of data barter emerge. Okay, so in this world, data now is a means of payment, in fact, right? It's a medium of exchange. So do customers really get paid for their data? Rarely explicitly, sometimes. So if I go to a Whole Foods supermarket in New York and I let them scan a QR code that links my grocery purchase to my Amazon Prime account, I will get dollars off my groceries. Right? That is an explicit payment for my data, for identifying me and tying it to my grocery cart. And I'm always shocked at how much they will give me. I go shopping for some basic things for dinner, right? So my cart, I'll tell you, salmon, lemon, some tea, some bread, some produce, some very basic things that I want to feed my family, right? No secret there. And yet, if I let them connect it to my Amazon Prime account, I might get $6 off that grocery cart. And I'm always shocked, like $6? You're gonna pay me $6 to know that my family eats salmon and lemon and, this doesn't seem like it should be worth that much. And I think, how on earth do they squeeze that much value out of this data, right? And so that tells me that this stuff's really valuable, or more valuable than I think most of us realize. So, you might have a supermarket loyalty card, airline frequent flyer programs. Some people install an app now that tracks your driving, and you can get an discount on your insurance. So these are examples of cases where we're made pretty aware that we're exchanging data for value. But there are probably lots of cases in which we're not made aware, and we should be getting a discount for our data. Not just should as in there's some moral imperative, but I think it's probably actually happening, because if it's not, the firm's not profit maximizing, right? This isn't about firms being kind and paying us. This is about, if you don't lower your price, you're not getting the optimal number of customers to maximize your profit. You're not setting marginal benefit equal to marginal cost if you don't lower the price, because lowering the price a little bit relative to what the price would be if there were no data will generate extra data and generate extra revenue for you. So if firms aren't doing this, they're making an expensive mistake. And I'm sure there's some firms out there, there's some corner store that's not optimizing along this dimension. They're not the ones we're interested in, right? These are not the big the firms that are generating lots of GDP and lots of financial value and so forth. The large firms should be savvy enough, and clearly some of them are doing this. So firms that don't discount for data are the ones that don't make strategic plans to accumulate the data. They're not really our cause for concern or our main focus of valuation. And remember, neither the customer nor the firm may be aware that this is really a data discount. It's just finding the profit maximizing price. But the profit maximizing price should be lower because of the value of the data that's being transferred. Okay, and that's an implicit data barter. That's like a lemonade stand transaction going on top of a transaction where there's also money being exchanged, right? And so that makes this not just a small piece of the economy, but really pervasive in almost everything that we do. Okay, so here's Whole Foods, Amazon Prime and Whole Foods Market. You just scan your code and you get money off your groceries. Yep, show ahead. Mm-hmm.
By data, it's not just the data or the groceries that will be purchased.
Right.
It's be data, personal data. You're willing to sign to give information about your household. Is that what?
No. It's just linking those things that I've purchased to an account that I already have with Amazon. I'm not providing them any additional, I'm not filling out some questionnaire or something like that.
Joël, you're not playing by the rules. There's going to be a Q&A session after. I'm sorry.
Oh, I'm sorry. I thought we were...
No. It's just that's the whole session is recorded on Zoom as well. And so if you ask questions during the presentation, and it becomes complicated to do the two things at the same time. Okay. So there's going to be a Q&A session after. Sorry.
In that case, I'll take my water now so I can get through the rest of that. Okay. So another way of thinking of what's going on here is that this is bundling, right? Bundling is doing two transactions in one. And what are the two transactions? Well, there's the product sale and there's the data sale. Remember we said at the lemonade stand, we could have broken that apart into a lemonade for $2 and data for $2. That's two transactions getting bundled into one. So what the customer is paying is the net price of those two transactions. That's not to say they're getting all the value of their data, but there's some amount of netting going on. So bundling is often seen as a pretty anti-competitive practice. One useful reason it's useful to look at this as bundling is we generally don't need new legislation or new laws or new enforcement arms or new economic thinking to deal with bundling. We could just attack bundling. And what does an unbundled transaction look like? Well, it would mean you'd have two prices for this transaction. There would be a price with data, and there would be a different price without data. We could call it a privacy protecting price, right? And then you could decide, do you want to have this presumably lower price, and then you reveal your data to the firm, and there's some understanding of what they might do with it. Maybe they'd sell it to third parties and so forth, but you'd be clearly getting a better price for that? Or do you want to pay this higher price, and then the firm is required to purge some information from their books after that transaction is done? Okay? And you could say, well, if we were to mandate that, wouldn't that be really costly for firms? Well, no, because what we would never want to do is tell the firms what privacy protecting price to set. And if you set the privacy protecting price at $1 million for this clicker, you don't have to worry about any of the logistics of selling clickers, because nobody's going to buy this for $1 million. You set whatever price would make you happy to deal with all of the the complications of having to purge that data, and the firm should never be worse off. They could always set a price high enough that they should be happy to have these two prices. And furthermore, they might even use it to segment the market. They could even extract some more gains from us by having different prices for people who like privacy and people who don't. So it shouldn't hurt firms in any way. But what it would do is allow some firm to say, if you charge $1 million for a privacy protecting transaction on a clicker, I now see an opportunity to come in and offer electronic goods at a privacy protecting price that's more reasonable, right? It would open up that as a new market. So why aren't firms doing this right now if it's so great for them? I'm not sure. I think it started as customers just weren't aware, right? And they thought, well, we can just get this data without actually lowering our price. And now that people are becoming more aware, maybe it's becoming more of a norm. But I think the other thing that's going on is, if somebody promised you a privacy protecting price, would you trust it? Right? Maybe what we need are some agencies or some private firms that verify this, that put a seal of approval on your privacy protecting price and say, here's actually the rating, right? It would be like a ratings agency for privacy. And that would enable us to transact with private transactions and then to see what it is that we're getting as a benefit for our data. Okay, so that's kind of what a world with unbundled data transactions might look like. So what's going on here now at the dynamic level of a firm? Well, this firm that does more transactions and has more customers will generate more data. More data will generate something that will create more value for a firm. We know firms are profiting from their data, so I'll call that higher quality for their goods or more efficiency for the firm, or maybe they're selling the data as revenue or something, right? But being more profitable in just about every model we'd ever write down will cause the firm to grow bigger, and it'll do more transactions and generate more data. So more data begets more data. This is what we call a feedback loop. This is the data feedback loop. And that appears in work that I do with Mariam Farboudi and others, and the paper that Roxana and I wrote a few years back. Okay, so what is this better stuff, higher quality, more profitability? There are lots and lots of ways in which data creates value for firms, but I'll put them in roughly 3 bins. First is it raises current profits. Data allows firms to choose better products, to manage their inventory better, to manage their transportation logistics better, to advertise to better customers, right? All of these things are going to show up as more productivity. But it also helps firms create market power, right? So firms with more data, remember, they grow bigger. More data begets more data, size begets size. We're going to have some enormous firms in this economy that ride this positive feedback loop. And so they could potentially exert monopoly power. So that's great for the firm. It's good for profitability. Not so great for social welfare, right? So right here we can see that when we talk about the value of data, there'll be a private value of data, and that's most of what I'm talking about today. But after we tackle that, we should really come back and start thinking about what the social value of data is, because that might be very different. And then lastly, and of I think particular interest for this audience, is that data reduces risk. Right? Data is information. And information resolves uncertainty or risk. I don't want to get into a vocabulary debate. There'll be some people who are absolutely certain that uncertainty means something that I just mean reducing a conditional variance, whatever word you want to put on that. Okay? But finance tools here are crucial. And the effect of this could be big, right? Just do the following thought experiment and think about, equity markets. And what's the compensation for risk? And what's the compensation for the riskless part of that, the riskless rate of return, right? The equity premium is something on the order of twice as large as the riskless return, which tells you that the potential value one can create by making predictions more accurate, by reducing uncertainty, by making things less risky or more predictable to investors, to firms, to agents in the economy, is potentially really large, right? And that's what data can help us achieve. It can basically help us make fewer mistakes. Now, I'll also mention here that in most of what I'm going to talk about, these are good uses of data. Data is doing great stuff here. It's going to help reduce errors and minimize waste and help firms be more productive. And this is a very rosy picture of data. My view is that data does make it more efficient. It makes people do stuff better, but it also can help them do bad things better, right? So it's not that data itself is good or bad, it's that it helps achieve goals more efficiently, and the goals could be good or bad. Okay, so I'm going to talk about firms pursuing profit and getting the goods to customers that need them, and all that stuff's good, but I want you to have in your mind that they could also be trying to do pretty harmful things to society. It's also going to help them do those things better. Okay, so now we want to think a little bit about how does data come about, what is its role in the production process. So here, so far I've been talking about data as sort of usable information, as knowledge, and in a lot of what I do, I kind of conflate this. And we do that a lot in information models, right? You get a piece of data and you automatically update your Bayesian forecast and you proceed with better predictions, and that's it, right? It's all costless and free, and but we all know that's not how the world works, because if you try to do empirical work and you get a data set, it doesn't analyze itself, it doesn't clean itself, it doesn't immediately reveal its insights to you in a costless way. This takes work. Right, so we could break this out into, there's something like raw data. And raw data doesn't necessarily mean that it's unstructured. It could be like the data set you just purchased. It's got lots of structured fields, but it's not created in just the right way for your purpose. It's going to take a lot of work to put it in the form that it needs to be to play well with the other data sets you want to. Firms spend time hiring people to put data in databases that match well with the other things that they use. So that's going to be structured for their purpose. And you could think of using data management labor to get from this raw data to the structured data. Okay, so you can think of data as being a stock of stuff. It's going to depreciate. So data yesterday is data today is the depreciated data yesterday. And then there's some input from some data management labor that helps to clean that stock of data. And then our structured data might be turned into knowledge. And what I mean by knowledge is really like an action recommendation. You should buy this asset. We should produce more of this product. We should advertise and target these particular customers, right? We should do this. And for that, you need some workers with slightly different skills. These will be workers with some domain knowledge, okay? So people who turn raw data into structured data are usually people with database, data backgrounds. People who turn structured data into knowledge, those are people who also know some finance or also know some digital marketing or also know they're the people with domain knowledge. And so you could think of knowledge as being some function of data and labor and putting those two together. Okay. So that's going to come back when we think about measurement, but that's sort of, I want you to have in mind that we can unpack this into many layers of data value chain. And sometimes I'm going to collapse this into one and just pretend that data and knowledge are the same thing, because it's not for the question at hand or the approach at hand. It's not that important to unpack them. But sometimes it is, and sometimes it's helpful for measurement to unpack these, because we can see these different kinds of workers being hired in the data. Okay, so I said it's important that data could be purchased or sold, and that distinguishes it from other notions like learning by doing. A key feature of this market and one that makes it really different from a lot of other markets we look at, is that data is non-rival, right? I could, if the data set is mine and I've generated it, I can sell it to you and I can keep it. And I can sell it to you, and I can sell it to you, and I can sell it to you. And we can't do that with a widget or a clicker, right? It's different because data leaks. Data leaks through prices, right? If you try to trade on data in a financial market, you're going to start moving the price, and we're going to see that, right? That's different. Clickers don't leak. If I use a clicker, you don't start getting little clickers in your hands. But if I use information, you start seeing some information. And so data known by others loses value, right? That's what we've referred to as strategic substitutability for decades. And that makes it different from other sorts of goods that don't usually have those kinds of utility spillovers. So firms selling data face something of a commitment problem, and this is something I've analyzed and worked with Song Ma and Ernest Liu, which is if you want to extract monopoly rents, then you really want to sell data to very few clients. But having sold data to a few clients, what would you like to do tomorrow? Sell it to a few more, and sell it to a few more, and sell it to a few more, and dilute the value of data. Right? And so we talked about using data sales versus data subscriptions as ways that firms might maintain monopoly power. Not because we want to advise firms on maintaining monopoly power, but we want to know under what circumstances should we be worried about monopolies in data markets, especially given that usually firms that develop a data set or their data is a little bit different from anyone else out there. So it's a very natural candidate for having some degree of monopoly power. Okay, so last piece of warm-up before we get into actual rubber hits the road. How do we value this stuff? The important issue of depreciation, right? If we can't figure out how to depreciate it, we can't value it. So here I want to do a little bit of math just to kind of work through why is this the right way to think about depreciation. So we said that data is used to predict something. So let's take an AR1, right? It's a very simple process to predict. So we've got this state theta. We don't know it, but we know it evolves with some persistence rho, some innovations epsilon. We'll keep them normal. And you've got some precision of what you already know. We might call this a prior. And the accuracy of that prior is the inverse of the conditional variance. So conditional variance, think expected squared errors, right? Your expected squared residual when you forecast something. That's the conditional variance. I just want to invert it because big errors are bad, right? So now inverting it makes big good. Okay, more precision, more data. Okay, good. So we're going to call that a stock of data because up means you have smaller errors. So now if I ask, what's the prior variance of tomorrow's state? Given today, what do I think about what this thing I want to forecast will be tomorrow? Well, I'm just going to take the variance of the left side, so the conditional variance of theta t plus 1, given some information I've got, and the variance of the right side. So I've got my persistence parameter. I got to square it, right? Because we're talking about a variance. I've got the conditional variance. That's D inverse, because I've just defined D to be the inverse of the variance. And I've got the variance of the innovations here. Okay? So if data predicts tomorrow's state, then a data point we can represent as, we'll call it S, tomorrow's state plus some noise. So now Bayes' law for normal variables says that the t plus 1 precision, how precise my forecast will be of tomorrow's state after I see this data point, should be my prior precision, that was D, plus the precision of each of the data points. And if I have multiple data points, I can add them up. So if I've got NS data points, and each of them gives me precision sigma s to the negative 2, then NS times sigma s to the negative 2 is the amount of precision that I add to my forecast. Okay, that's just Bayes' law for normal variables. It basically says precision tomorrow is yesterday's, the prior precision. That's this thing. It's yesterday's precision, but I'm kind of discounting it. I'm discounting it by persistence and the innovation variance, and then today's new information, however many data points and the precision of each of those data points. Okay. So what that means is that tomorrow's data is the depreciated data. That was the depreciated, that was the variance up there. I've got to invert it to get a precision, plus the new data inflows. Okay, So this is just working with Bayes' law. This is for normal variables. You can think of this an approximation to non-normals, right? There'll need to be some adaptations. What this basically tells you is this is kind of like capital tomorrow is depreciated capital stock today plus investments. Okay, the investments are the new data points you got. That's the new inflows into the stock of data. And then this implies that the depreciation rate is something not linear. So what's the depreciation rate? Well, it's 1 minus 1 over persistence squared plus the innovation variance times the data stock. Okay? So what this teaches us is that data depreciates faster when it's abundant, because when it's abundant, your precision is really high. And so why are we losing precision? What's the essence of data depreciation? That data yesterday was about yesterday's state. And today's state is a little bit different, right? Yesterday's weather was a little different from today's, so the data about what yesterday's temperature and precipitation were, they're informative about today, right? One day to the next is not likely to be that different, but they're not as good as data about today. Okay, so it's depreciating because there are changes in the state, right? Because of the variance of those state innovations. And the relevance of yesterday's data to today has to do with the persistence, right? So those two things determine the depreciation rate. So data depreciates faster when it's abundant and when the environment has volatile innovations, right? In the, if we had very crazy swings in weather from one day to the next, then yesterday's data about yesterday's state wouldn't be informative at all about today's. Okay, so that's how we can think about conceptualize depreciating data. We need to know how persistent is it, what we're trying to forecast, and how variable are the innovations in that process. Okay, so that's all the background, the context of how I'm thinking about how the data economy works. Now let's turn to actually valuing some data. Okay, so 6 approaches. I probably have something like 20 minutes left, 20, 25, is that right? 25. Okay, great. Excellent. We'll go through these in good time. Approach 1, complementary inputs. So when we use data, we usually use, the fundamental problem is we can't observe data, right? We could count bits on a server somewhere, but that's not really the right way to think about it because a lot of it could be very noisy, or it could be those bits are very precise and have high value and they're good. So you really want to, it's hard to take a ruler to this, right? And also firms just don't disclose how many bits they have on servers. So we can't observe this. So we got to back into it. So how are we going to back into it? Well, the first approach is to say we use things with data. Maybe we can observe those things that get used with data, and then through the lens of a model, we can impute how much data there might be or how much it's worth. Okay? So suppose we produce knowledge using structured data and analyst labor, right? That's that pyramid approach that I showed you before. We had raw data, structured data, and knowledge. So the knowledge is generated by data to the alpha, labor to the 1 minus alpha. Okay, so we've got constant returns to scale. So new structured data is added to the existing stock of structured data with data management labor. Okay, so we looked at this before as well. This was on that knowledge triangle. Data depreciates at rate delta. Right now, I'm pretending that's a constant rate, but we could stick in that depreciation rate we just derived. Then we could estimate the stock from hiring and wages of the analyst labor, the L's, and the data management labor, the lambdas. If we can see how many workers does the firm have in each of these 2 categories and how much are they paid, that's plenty of data, plenty of information to impute what must D be, right? And the units of that will be in dollars or euros, or it's going to be in value. What's the value of that data, given that you're willing to pay this much to your workers? So this is what Simona Abis and I do in an RFS paper. There's another approach to this, which is Brezhnev and Brynjolfsson do something along this line with what else do you need to use the data? Computers, right? Nobody's doing this stuff by hand. And so they got some data on IT capital. Now, they don't use a structural approach like this. They use IT capital as a proxy for data. But if you've got your hands on a good data set of the IT investments, which in principle are clearly observable for a firm, but are a little bit harder to get good data on, you could do a similar structural approach to valuing data that way. Okay, so that's the first approach. I'll show you some results from that in a second. But first I want to introduce the second approach, which we'll use in conjunction, which is a value function approach. So the same tools macro used to value a capital stock might work well for data with an adjusted law of accumulation. So why might you want to use a value function approach? Because data does not fully depreciate from period to period. It has payoffs over a time horizon, right? Data today is still somewhat valuable tomorrow, and the next day, and the next day, and the next day, right? So how might we think about that? Well, with a recursive approach, with a value function, with a Bellman equation. So you could say that the value of data is I'm going to choose some capital and some labor, and I'm going to have some productivity that results from data, or productivity, or profitability, whatever you want to call it, something that turns capital and labor into payoff. Got a standard production function here. I've got to pay my labor. I've got to pay for my capital. And I've got a discounted value of data tomorrow. Right? That looks like a really standard macro or macro finance approach to valuing an asset. But what's different here is that we need a law of motion that links data today to data tomorrow. Right? How do we get from state t to state t plus 1? Well, that's that depreciation equation that we just talked about. So data tomorrow is the depreciated data, right? We derived that from Bayes' law. And then the new data inflows. What are the new data inflows? Well, here you could have a bunch of different theories. You could use any or all of these or others, right? Where does data come from? Well, maybe it's a byproduct of transactions, right? So maybe it's like the lemonade stand. You sell stuff and you get data. Maybe you purchase data sets, right? So it could be that new data inflows come and you have to then include that expense in the in the payoff function, but maybe you buy these data sets, or you do both. Or also you could think about using labor to process new data, right? You could have the labor, data management labor show up here in new data inflows. And so it's costly to generate them, but the raw data you sort of harvest from the internet like grass in the field. Okay, any of those could work, or you could pair them together. But so then this gives you a way to think about maybe calibrating an economy to aggregate moments and trying to back into what's the value of data if you can measure some of these things, right? Why is it useful to think about these theories of data inflows? Because I can measure the transactions, and I can see data purchases and sales on data markets, and I can measure the labor. I can see the hiring of new workers. Okay, so what Simona and I did was to merge these first two approaches together. So measuring with hiring data, with wage data, the data management workers, the knowledge workers, the analysts, and estimating a value of data. This is for a particular sector, which is a subsector of finance, which is financial analysis, and backed into how much was data worth for these firms in this sector. And what we find is that there's about a 33% growth over this 4-year period. And data here is growing so you might expect this to grow exponentially. A lot of people thought that we'd see much more rapid growth in data. I mean, 33% is a lot for an asset growth over a short period of time, but why isn't it growing exponentially? Server data and flops and transactions and data processing is growing exponentially, but data also here has diminishing returns. If you're using data to make a forecast, you can only drive your forecast error to 0, right? So it's natural for data that's used for prediction to have diminishing returns. If you've already got 1 million data points in your data set, the million of first isn't doing a whole lot for reducing your forecast errors. And so the combination of this convex growth of the amount of data and the diminishing returns and the value of data, and it gives you something that's neither convex nor concave, looks kind of linear-ish. Okay, and that's the combination. That's the conflict between these two forces. So data here is growing for 3 reasons. We can back this out because we've got a structural model, so we can pull apart the growth and the value of data, and these are roughly about the same magnitude each, which is there's just more data. So we see firms hiring more data managers. It's telling us that they're probably managing more data. Second is there are more analysis workers that make each data point more valuable, right? If you hire more workers to work with capital, your marginal value of capital goes up. If you hire more workers to work with data, the marginal value of data goes up as well. And so that's increasing the value of the data stock. And that was kind of an interesting finding because there's lots of discussion right now about data and AI replacing labor. And in this sector, in finance, that's not what we see. We see firms that adopt AI, and we know they're adopting AI because we can see that they hire a worker that needs to have AI-specific skills. If you hire a worker that needs to have knowledge of random forests, you're experimenting at least. You're using AI in some capacity. So those firms are not replacing workers. They're growing workers. They're becoming more productive and more profitable and hiring more analysts. And lastly, firms are becoming more productive in this sector, particularly the ones that we see adopting AI. Okay, so higher productivity raises the value of data, more workers to work with data raises the value of data, and there's just more data overall. Okay, so this sector is kind of growing on all fronts. Okay, so a different take on this, approach 3. We could value data as the present discounted value of the revenue it generates, right? That seems like an obvious way. This is how we would value a lot of financial assets or firms. So how do we isolate data from other revenue is the key question here, right? Not that hard to see the firm's revenue and discount it, but how do we know what piece of it came from data? Okay, so this is potentially doable, but you've got to have a really clear idea of how data generates revenue, right? Which basically means you have a model. It could be a formal model, it could be a model in your head, but you got to know something about how data generates value. So this is possible to do and has been done in a few papers where we think about using data for creating a portfolio. Why a portfolio? Because, well, it's pretty clear. We have a clear model of if you've got better information for predicting tomorrow's returns, here's exactly how that translates into future profits, right? And so you can take that data and you can take that model and you can value a given amount of data with it, right? And so a bunch of people have done this. Manela and Kanan, work by Davila Parlatore, work by Kong-Shi Xiang. Joel has worked on this. What's the value of information? Now, one problem with doing this is that data has different values to different agents, right? It's what we'll call a private value asset. So in the context of portfolio choice, that might seem kind of strange. Like, isn't if I give you a piece of information, I give you a piece of information, can't you do the same thing with it? Can't you form the same optimal portfolio? Well, yes and no. So let's take the portfolio case, because that seems like data should be the most homogeneous in value. But then let's think about some heterogeneous investors. So they might have differences in their size. They might have differences in the price impact when they trade. Maybe some of them only trade small stocks. Maybe some of them only trade value stocks, so they could have different strategies. Data is going to have wildly different values. The same data set we valued for investors with these various characteristics. And we developed a means to do this because we don't, in principle, in order to value data, you have to know all the characteristics of all the investors in the market, right? Everybody's risk aversion and everybody's size and everybody's so forth. And so we developed a way of doing this if we want to value your data, we just need to know your characteristics and some sufficient statistics about the market, like what's the expected mean, the expected variance, and the conditional variance. So then we just valued the IBIS data set for everybody, the same data, right? Why that? Because it's run of the mill, it's been studied a million times. But what would it be worth to this type of investor who does value trades? What would it be worth to an investor that's got this size portfolio and invests in all asset classes? And we found the same data is worth only $10 to some investors and is worth 1.2 million to others. And we could make that arbitrarily high if we just made them bigger and change the risk aversion. But the point is, for some perfectly plausible types of investors, we got wildly different values of data. And that doesn't mean that there's nothing wrong with that. That doesn't mean this approach is bunk. It just means that this is not a financial asset, right? We think of a financial asset as having one value because it generates money for everybody and we're valuing it in money units. But data has very different uses. If you're trading small stocks, this data just sucks. It's not very useful for you. And so you don't value it very much, right? This is like if you buy a data set and you're really excited, you've got a high willingness to pay for it because you're gonna write an awesome paper with that data set, that's great. If you give that data set to me, I have no idea what to do with it. And so what's my willingness to pay for it? Just about nothing, because I don't have a good idea to pair with that data. So data has different uses and therefore very different values. So I put this up mostly to remind you that when we think about valuing data, it's not a value for data. It's a value for you and a value for you and a value paired with your idea and a value that works for your technology or your strategy or what have you. Okay? So another way we could think about the value of data is that data allows agents to make better choices, right? This is getting back to data as information, as for prediction. Why do I want to predict something? Well, presumably I have a choice to make, and I want that choice to reflect something that I don't fully know, right? If that's not the case, then I don't know what we're doing trying to gather more data, right? And everybody's uncertain about something in the world, and choice under uncertainty is just pervasive, and the firms have to deal with this all the time. So let's say you're choosing an action Q, and you want it to co-vary with something R, right? Q could be number of shares of an asset, and R could be the return, but we could also be thinking about, do you want to invest and put more into building the firm in Indonesia or Kuwait, right? So the expectation of the product we can write as the product of the expectations plus a covariance between the two, right? And data doesn't systematically make your expectations better, it changes the covariance. It allows you to choose a Q that's closer to the R, that you couldn't choose if you didn't know something about the R, right? So now what we're working with is really measurability restrictions, right? And that's just sort of a probability theory way of saying, no matter what model you write down, I cannot choose an action that systematically covaries with something unless I have enough information to predict it. Okay? I might choose an action that covaries less with this thing because I face all kinds of constraints, but I can't covary more with it without information, regardless of the economic environment. So agents cannot achieve high covariance without information. They could have good data and no skill at analyzing it. They could face constraints. So this is really a lower bound on the amount of data they have to have. They could have more. But it's useful because this is a way of approaching data measurement that is a little bit more agnostic about what the economic environment is. So we should then go measure these covariances, right? We can see outcomes, we can see actions, we can back into how much data must you have had to make those decisions, right? So what does this look like in practice? This looks like measuring a portfolio alpha, right? Did you systematically pick stocks or buy at the right time or do something that you must have had some data to make possible? It could be a customer click conversion rate, right? Did you serve ads to people that systematically clicked through more than we would have predicted unconditionally? You must have had some information. I mean, okay, you can get lucky once or twice, but to systematically do this over a period of time repeatedly, you have to have data that makes that possible. So covariances might be an approach to measure. They also sometimes show up as aggregation effects. So this is sort of the basis for my work with Jan Eckhout, where we were thinking about a firm choosing a portfolio of goods to produce with unknown returns to producing those goods, right? And a firm with data will produce more goods that have higher returns. Well, what do we call that in IO? We call that a higher markup, right? Price divided by marginal cost. So they want to allocate more of their production portfolio to goods with higher markups. Well, guess what? When people measure markups at the firm level, they come up with numbers that are pretty different than when they measure them at the product level, right? You can measure a markup on a 12-pack of Diet Coke and its UPC code, and people do that at the micro level. And then when you turn to the firm, you're like, wow, we got a pretty different measure of markup. And when they go to the industry level, they're like, wow, this looks huge. Well, guess what? At every level, there are aggregation effects. And the aggregation effects are firms using data to tilt the portfolio of goods towards the higher markup products. And the firms that have lots of data do more of this tilt, right? Because they're using data to pick the products that have higher markups. So even if the product markups all stay the same, your firm markup can be going up because you're getting better at producing more of those profit maximizing products. And the firms that are really good at this, the ones that have more data, remember the data flywheel, the data positive feedback loop, those firms grow big. So then when we measure industry markups, we weight them more, and we weight more of the firms that tilt their portfolio of goods, then we get an industry aggregation effect. So they've known for a while there are these aggregation effects, and they think of them as problems. Right, where something's going wrong. It's not going wrong. This is data showing up. These are covariances. Aggregation effects are covariances. They're covariances between the weight you put on something and the value of the thing you're measuring. And those covariances can easily be generated by data. So one place to look for data is in aggregation effects. If you see aggregation wedges, those are always covariances. They might be generated by firms' use of data. So another way of thinking about covariances is we could think about one action firms take is to make a forecast. They could forecast their earnings. And so the work by Alexander Kohlhaas and Vladimir Asrian is looking at firms' revenue forecast errors over time and finds that, in fact, they go down. Firms are getting better at predicting their own sales, their own earnings. And so we see this is true both whether you measure by absolute error or root mean squared error. But by looking at forecast errors of a firm, you might get some insight. You could back out how much do they need to know in order to make better forecasts. So this suggests the fact that they have smaller errors over time, that the data sets of these firms are growing. Okay? So we could think of that as an example of a covariance. And then you can convert that to the value of data by estimating the change in profits due to a change in the forecast error, or you could use a structural model. Right? You probably want to deal a little bit with identification in the first approach. Right? They could be more profitable due to other reasons and also have lower forecast errors, but you need an extra piece to turn these precisions or these forecast errors into profits, but you could do something to back out the value of data. Okay, approach 5, we're getting there. Market prices. Why don't we just look at the price, right? And we have marketplaces for data. There are platforms like Snowflake, DataRaid, where there are all kinds of data sets for sale, and they have posted prices. Keep in mind that this is the intersection of supply and demand. So what we've been talking about so far is really the private value of the firm, of a firm or a portfolio manager or what have you, their valuation for the data. There's probably a whole demand curve, right? Because we said they're private valuations. That's tracing out a demand curve. And what this is a transactions price. And this is going to be an intersection of supply and demand. There's nothing wrong with that, but I just want to point out we're measuring something a little bit different now, right? The question of what's the value of data, we've turned from sort of the demand value, the customer value, to the market price, the intersection of supply and demand. So this should be a lower bound on the value of anybody who buys it. You shouldn't buy it if your valuation's lower, right? But your valuation could be a lot higher than the price you actually paid. And keep in mind that the value to a buyer is often depends on who else knows the data. And that's important when you think about these public marketplaces, because here, this is data that it's very clear they will sell as many copies as people are willing to buy. So this is not really representative of the kind of data that's being transacted, the stuff that's posted on public marketplaces. And when you look at it, you can see quite clearly that it's not Amazon telling you, how many black shoes they sold. A lot of it is B2B stuff. It's list of contact information. It's geographic coordinates of points of interest. There are firms selling transactions data, but it's an interesting selection of firms because they're ones where their business model is not undermined by you knowing what they do. So for example, Grubhub, which is a restaurant delivery service, will sell information about the restaurant's sales in particular locations, right? That doesn't undermine the delivery service business model, but it probably hurts the restaurants, right? By having people know what it is that they're doing that's selling well and what might be profitable points of entry. Okay, so that's one place you can look, and certainly we get some prices for that. We have to interpret them correctly, and we have to understand this isn't a representative sample. We could look at market prices for firms. So market to book, right? That should tell us about all kinds of intangibles. So, Creuset Eberly, Peters Taylor, many others have used market to book as a way of measuring intangible assets. But keep in mind, this has already kind of been claimed by branding, by patents, by organizational capital. There are many forms of intangible capital. Some of them overlap with data, right? Customer capital is probably an overlapping set with data, but it's not quite the same thing. So Bello, Gala, Salomao, Vitorino, Eisfeld, Papanikolaou, many people are working on this. And really the question here is, how do we tease apart the value of data specifically? So if you told me this firm had lots of valuable data and I didn't see a high market to book, I'd be a little suspicious. But it's not like you can just tell me there's a high market to book and I could infer that that's necessarily all the value of data, okay? And lastly, all of these presume that market participants know how to value data. And I mean, what I'm coming to you with is, here's some approaches. We've got some ideas. It's pretty rough. And then, some banks ask me to come in and teach them about the value of data, which means that they don't know a whole lot more than I think with markets, some markets, we've had lots of experience and we've learned how to value assets and there's common understanding. And there are other markets where there are new assets coming in and we could be a little overly exuberant or we could have lots of mispricing. I'd be open to the fact that market prices are not perfectly informed in this case. Okay, last approach. I'm almost out of time. Cost accounting, a book value approach to valuing assets is to just accumulate the sum of costly investments, right? And why not do this for data? Well, you could take some of that data management labor and you could add it up. And this is an approach that's been taken by some government agencies to start to think about data value. But keep in mind that most data is a byproduct of some other economic transaction, right? Back to the lemonade stand. We didn't see the cost of the data there, right? There was a cost of the data because if they hadn't gotten the data, they would have otherwise charged $2 for the lemonade. But there wasn't an explicit cost. So we're missing the discounts. And GAAP accounting rules won't allow us to count data unless it was purchased, right? Purchased data sets can be listed as an asset, but internally generated data cannot. So there's this implicit cost of data, which is firms are probably lowering their price to get more of this data. That's sort of a payment, but we don't see how much that payment is. It shows up as a discount that we can't break out. So this could work if we have good systematic ways to impute the data barter discount. This is something I'm very interested in. Can't say I've figured out. I don't have a good way to crack this one, but I think it's a great question. Okay, so that's it. We went through 6 ways. They're not exhaustive. There are some ideas about how we might get at this. We're probably going to need a combination of these tools, but data is one of the most important. We know it's one of the most highly valued assets in the modern economy, but it's also incredibly difficult to observe, to measure, to put a price on. We're going to have theory and measurement work together here, right? We can't just go out and measure things directly because we don't have great data on data. So what do we want to do? Quantifying the data barter. How much are firms discounting for data is a huge open question that I think will need lots of different cracks at. The private versus the social value is a big question. I've been talking really exclusively about private value because I think we have to start there, but I don't think that's the most important thing to get at. I think eventually we need to ask questions like, what about privacy? What about price discrimination? What about undermining competition? How is society being impacted by this? Data accumulation of firm life cycles is a big question. Size, scope, competition between firms. You know, data and AI are going to generate enormous gains for society. And a huge question really is, how will those gains be split? Right? And that a lot of that will be about the competitive environment. How competitive is it? And finance has a lot to say and help us understand about how this is evolving and what might be done to markets to influence how this, you know, benefits you know, customers, firms, workers, et cetera. So asset pricing and corporate finance tools are essential to measure and value data, and there's lots more work to be done. And I'll just end with a new textbook to help you think about some of these issues, co-authored with Isaac Bali, just released a few months ago from Princeton University Press. Thanks, everyone.